this exercise and the next exercise are focused on geometric transformations. That's a concept that I introduced you to earlier in this chapter. And I really like this because this connects really well to understanding how graphics works in video games and cartoons and VR and so on. When you are playing a video game, the characters and the blades of grass and the wall, everything is represented as a set of coordinates. And as that thing moves around, as your player moves around, then basically just a transformation gets applied to those coordinates, and then that redraws the new location. And then it gets updated over and over again at each time step. And the transformation matrix will change when you press a button or move in a different direction, and so on. Now, in 3D environments, in 3D video games, the transformations are a little bit more complex. It's a little bit more involved, especially when you have animations and physics involved. But the underlying principles are exactly the same as these really simple examples here. It's just that, things just need to be a little bit more complicated if you're working in 3D. Okay, so here's what we are going to do. Take this transformation matrix T and apply that to a set of points here. So you see the original points in black. It's just a circle. And then you apply the transformation of these coordinates. So each of these dots is an XY coordinate. We stack them all up, and that gives us I think it's 20. Okay, I don't say, well, it's a m by 2 matrix that we store this as. And then we just apply this transformation matrix T, and that gives us a new set of points, which is illustrated by these gray squares over here. Okay, so that is basically the goal of this exercise. And now I will switch to Python and show you my code solution. So here we have the transformation matrix. I have it split over multiple lines in this file just to make it easy to read. But yeah, this is just any standard matrix. There's nothing particularly special about this matrix. Okay, here I define the set of points. These are linearly spaced numbers. It goes from 0 to 2 pi. Now, it might look a little weird that I have 2 pi here, and then I'm saying minus 2 pi divided by 20, and then in 20 steps, what is up with this subtractive factor? That's actually because we want to go one complete cycle around the circle, which means that we actually do not want to stop at 2 pi because 2 pi and 0 are the same angle. I'll show you that in a moment. Okay, so basically I'm just taking the discretization rate and I'm subtracting that off from 2 pi. You could do this a different way if you wanted. You could start, instead of 0, you could start at that discretization and then go up to 2 pi. So now we're not starting at 0. Either way is fine. And yeah, you could also have some points overlapping in there. Okay, let's see. So then we have cosine of that angle and sine of those angles. This will create the circle. This I'm calling orig points. These are the original points. And then the transformed points is super simple. We just do a matrix multiplication. This is, by the way, the reason why graphics cards are designed to implement matrix multiplication. When you're working with a lot of graphics, you just have to do a lot of matrix multiplications, and you want them to be implemented really fast and really efficient. And this is exactly the reason, this is exactly the motivation underlying graphics cards. Of course, now, GPUs are used for a lot of other purposes like deep learning and mining Bitcoins and so on. But this is the original motivation for developing GPUs. Okay, so then from here, it's straightforward. We just plot the original data points and the transformed data points. Okay, and then, yeah, that produces this image here. So if you haven't already, what I encourage you to do is just, try playing around with these numbers. Just try changing some of the numbers and the different elements and see what impact that has on the results. And as promised, I will also show you what happens if we just set this to go from 0 to 2 pi. And I don't think we will see that there's overlap. Let me see if I can do 0.1, maybe just, I want there to be a little bit of overlap. Yeah, you can see it here, that there's a tiny bit of overlap. These points here are really close to each other. So I hope you enjoyed learning about transformations, geometric transformations in this exercise. The next exercise, we will take this one step further and do some animations. We'll make some data animations using matrix multiplication.